on this computer. Yes, now we are recording. Okay, so we are asking about the quiz before we, of course, say it's open for 2 days. Yes, of course, we of course say that it's open for 2 days since the beginning of the semester. But you know that I also say that because of what is happening now, the quizzes are only the day of the class, and it's going to be quiz time, the class time, and I will post it, but it's Thursday at class time sharp. Okay, locate the centroid of the X area. So first, the first thing that you have to do is equation for the centroid. And one of the things that people, even though it's a stupid thing to do, but I don't know, and I'm providing the equations for the exam, but still people do it, I don't know, and they remember for centroid, if this is what we are doing, this is for centroid, but for moment of inertia, this is y squared dA, it's not x. So if you want to calculate I sub x, which is not the case, we could do it, but it is not the case, that will be the integral of y squared dA. So sometimes they mess up here and they put x squared dA. So don't do that, please, okay? Now, x squared dA, and then we are gonna go back and we're gonna do the other direction. Now, there are two ways of doing this. If you're doing with the x direction, I always say the straightforward follow procedure, try not to mess approach will be, look, I'm gonna do the x bar, so that means that somehow I'm measuring a distance x. That's what I'm saying. Somehow I'm measuring a distance x from there, and my differential of area. Then I try to. Sometimes it's not possible, but I try to make it perpendicular to that that distance. And then I say, okay, then this is dx, and my dA here, differential of area, is that shadow region, this one that I have over there. Now that region that I have over there is a small rectangle. It's a differential rectangle. I know the base is dx and the height should be this height. I don't know how to call that height. You can call that height small h if you want to, let's say h. So my differential of area is going to be h times dx. What is your whole problem, your overall problem in this problem? Yeah, nice, really nice overall problem in this problem with the problem that we have in problems with the problem. What is the overall problem with this situation? The overall problem with this situation is that you need to determine that value for h. Now, what this h is measuring is vertical distance, meaning I have to isolate whatever is happening in that y-axis over there. The value for h, that h is going to be, at any point, is going to be that distance, and that distance is measured for y in the equation 1. When this is here, this is x. When this is here, this is x also. So that distance is y equal x. That's what that distance is. And the other distance, the bottom distance, is this one. That one. And that's defined by the value of y in that function. That's what it is. So by ones, we're measuring y in this, and then now we're measuring y in this one. And this is 1 over 100 x squared. And the distance that I'm looking for is just this little thing here, h. And that h is no other thing than this distance minus this distance. Meaning my differential of area is going to be what I call h, meaning x, because this is x from here to here, x. Oh, I shouldn't, yeah, well, y equal x, I put it here, right? Let me call it y1, and let's say this function is y1, and this is y2, minus y2. So y1 is provided by this equation, which is x, minus y2 is provided by this equation, which is 1 over 100 x squared. And that's basically what you have. Once you have your differential of area, and you're sure that that differential of area is correct, then you don't have any problem whatsoever. And you can solve it. One of the things that I always do, I don't give you this value, for example. You don't know that value from the beginning of the problem. But you don't need that value from the beginning of the problem. You know, as a matter of fact, you don't even need that value from the beginning of the problem, because you can figure those values out. How? You can figure those values out because you have two equations, and you can find the intersection points for those two equations. So you can be able to find 2 points in that particular part, for those particular functions. But let's say that I give you one value, and then there are students that do not solve the exam because they couldn't find that. What is that? Times dx. Yes, I haven't done anything. Thank you. Times dx. And they don't figure this out. But you have the equation, and you have the value for y. So you can plug it into either equation, if you put it here or you put it here, and then you can find for x equals 100 millimeters. And that's about it. Now, once you have that, you can come into the general equation and say, okay, this is gonna be the integral. I don't know what I'm using green color because it's sustainable. I don't know. X times dA, and dA is this. Divided by the integral of dA, and the integral of dA is that. Now, the other important thing here is that you have to identify how are you conducting this integration. And I always say that if your differential of area is this one, you have to sweep the whole shape in this direction, from left to right, differential of area, like that. So you have to go from the distance when x equals 0 up to the distance when x equals 100. Those are going to be your integration limits over there. You can do it by parts, you can do it together, you can do it whatever way you want to do it. If you want, you can solve this first. So the integral of differential of area is going to be area. It's going to be the integral of this. You can do it like that if you want to. And I'm going to tell you afterwards why I'm doing it like that. dA, dx. And then if you solve for this is going to be equal to x squared minus 1 over 300 x to the third, right? X squared divided by 2, x cubed divided by 3. So this is going to be the value evaluated between 0 and 100. So for x equals 0, work this out with me, guys, please, because I don't have these results. So x squared is 10,000 divided by 50,000, 50,000. 50,000, no, 5,000. Minus 100 the third divided by 300. Is that correct? Okay, units. Millimeters to the fourth, no, square. Millimeters squared. And now you can solve the top part also. And you can solve the top part, not to the fourth, you see? You did the same thing that I did. Well, it's gonna be to the fourth, I'm calculating areas. To the fourth is when you do a moment of inertia. Now, the top part of the integral is gonna be x squared minus 1 divided by 100 x to the third. The integral of that, 0 to 100. I'm just multiplying x times x squared. and this is x to the third divided by 3. So you have that. And then we're going to do the integration of this. So this is going to be x to the third divided by 3 minus 1 divided by 4 times 100, x to the fourth between 0 and 100. Okay, and we can evaluate this also, and the numerator of this is going to be equal to, now it's going to be to the 4, by the way, millimeters to the 4, the units here. So this is going to be 1000 to the third divided by 3 minus 100 to the fourth divided by 400. 83,333.3. If you feel like your OCD is killing you right now, because you are not putting any type of units here, these units should be millimeters to the fourth, to the third. These units here, millimeters to the third. Why millimeters to the third? Because when I divide by the area, millimeters to the third, when I divide this by this, I have to get a distance, a linear distance here. So that's the reason. And then you're gonna say, oh, but this is why this is to the 4. Yeah, this is to the 4, but this is coming from the integral that is taking into account other things. But the units should be that. So then x bar is gonna be 83,333.3 divided by 1666.6, and that is equal to 50. Please don't be the guy that put 50.000000002, because I always receive that type of answers also. 50 millimeters. Questions regarding this? If not, we can move to the second part, which is finding the easy. Of course it is easy. And however, it is easy and it's one of the most complicated values, most complicated problems that you can have because you are using two equations for that. Let me check something really quick, and then if it works, I'll tell you. If it doesn't work, I don't tell you. So this is gonna be this minus there you go. Yeah, what I was doing is something what are you doing there? And y equal x, what do you use? Okay, now those are the type of things that you're asking now. Okay, now I'm gonna go and check your questions. Remember guys, this is an online class that we're having. So what I was doing here is just regarding the area. As you can see, this is a parabola here. But it's not just a parabola, it's a triangle and a parabola, which is also, let me see something, 100 squared divided by 3. It's not. Do you see? This is a triangle here, and this is a parabola. And I know if it's a real parabola, that's why I say let me try it. And I know this is a real parabola. What do you mean by a real parabola? Well, this is a parabola equation. You know the area of this portion is 1/3 of b times h. And the area of the triangle is b times h divided by 2. So if you want to calculate the area graphically, not by using integrals, you can say b times h divided by 2 minus 1/3 of b times h. B times h divided by 2, and 1/3 of b times h will give you this other part here. You're saying Don't do it like that, but you can also do it. Okay? Now, let's work with the second part. The second part is finding the moment of inertia with respect to the y direction. Moment of inertia, centroid. Centroid. Now let's find y bar. What do I mean by y bar? Okay, y bar means if you're using the approach step by step, as I said before, easier to not mess approach, then you have to do that because it's the same thing that we did here. You see the same approach that you have over there, meaning you're going to be measuring somehow, somewhere, a distance in that direction, y, distance y, and your differential of area, if you can make it perpendicular to that area, meaning this is going to be dx, dy. And this distance, I don't know, you can call it small b. Small b. So your differential of area for this case is going to be a small b times dy. Now that small b, if you look closely to this, is going to be this distance, which is the value for x. And if I call this equation 2, that will be x2 minus the value for this distance, which if I call this equation 1, is going to be x1. So my b distance is going to be equal to x2 minus x1 times dy. What is x2? X2 is the value, whatever value I have here. So I have to solve for that. I know that y is 1 over 100 x squared. So if I take square root of this, it's going to be y to the 1/2. Square root of this is going to be 10. Pass it to the other side, 10. And the square root of this is going to be just x. So that's going to be the value for x2 corresponding to this equation. Then my differential of area will be x2, which is this, 10 to the 1/2 minus this, which is just y here, x equal y, multiplied by dy. You can do that. Then you apply your equation, that's it. Y bar equals the integral of y times dA, but dA is this one. Divided by the integral of that. Now the limits of integration. My differential of area this time is like that, so I'm going from here to there, meaning from 0 to this 100. Okay. Yes, I can use a vertical strip instead, but we're gonna be going to do that now, the next step. Now, first thing first, let's solve the top part. Why the top part and not the bottom part? Okay, if you want, let's say that you have been working with this a little bit, and you know some little tricks about this. We already calculated the differential of area. What is the integral of the A? The integral of the A is A. Now the area shouldn't change because I selected one strip like that or I selected one strip like that. The area is the area of the shadow part. And that we calculated and it was this one, 1666.6. So I could use this area if I want to. I don't have to go through the whole integration again because I already know the area and I can focus only on the top part if I want to focus on the top part. Now let's say that you don't know that. If you don't know that, then you have to go and run it everything from scratch. So the top part will be, this is y to the 1/2 plus 1 divided by 1. So that means that this is 3/2. So the integral 0 to 100 of y to the 3/2 This is 2 over 2, and this is 1 over 2, so 3 over 2 minus y squared dy divided by the integral of this. I'm just going to put the area there because I know the area. Now, if you do the top part is going to be 4/5 or 5/4, because this is, now it's going to be, if I add, this is going to be 4/5 here. 4/5 of y to the 5/4 minus y to the 3rd divided by 3 from 0 to 100. That would be something. Yes, somebody's trying to say something.
You forgot the 10 multiplied by the y to the 1/2.
Thank you. Thank you. That's why you're here. Then why are you so shy? Anything else that I forgot? And thank you for letting me know now, because I was already finishing the calculation.
I think it should also be 2/5 multiplied there, not 4/5. And it should be y to the 5/2.
Why 2/5?
Because when you're doing
Yes,
the
you're
integration,
right. 2/5.
okay.
2/5. So this is 5. This is also 5 divided by 2 here, and this is 2 divided by 5. Correct?
Yes.
Okay. Now, yes, you're right. You're right. So this is live, as I told you. I'm not solving this, and the next one is going to be even worse, because in this one at least I have some any values. 666.6. And what is the top? Do you have the top part? You have the answer for the top. Guys? No? Yes?
Working on it.
It's a nice number. 666.6. Look how nice.
Yeah, I got the same.
So when you divide that, we get 40. Now, once you have this value, I also told you to go an extra step, and the extra step is plot your results, because sometimes by plotting your results, I have to, I'm sorry about this, guys, but I have an emergency surgery yesterday in my mouth. It's killing me. So anyway, this is 40. Now, if you go here to the original plot, the x that we calculated was 50, and the y that we calculated was 40. 50 somehow measures this, 50, half of the distance, and 40, which if you realize that should be, because this is kind of symmetric, and 40 in the y direction should be somewhere over there. Now, yeah, it's heavier in the bottom part because there's more material, let's say like that, in the bottom part. So this is it. Now, this is the location of the centroid, and with that, it should be done. Now, somebody was asking me when I was doing this, why I didn't use the same strip, and somebody was saying, oh, if I use the same strip, let me print that out again so I can use a new sheet of paper, a clean one. So print. There you go. Okay, now I have a new paper here, and somebody was asking, oh, what once you have this for the first part of the problem, that's what we had for the first part of the problem. We say this is our differential of area, and the distance that we measured was this distance, x. That was for the first part of the problem. And now we're trying to do the second part. But somebody was telling me, okay, yeah, I know the equation is this. And this we know, by the way. But the differential of area we know. So why do I have to change my differential of area? No, you don't have to change your differential of area. You can measure y also and keep the same differential of area. Now look what happened here, because this is where the tricky part comes into play. Look at this. When I measure this distance, that distance goes from the axis to the centroid of the shape. Centroid of the shape. That's it. In this case, this shape is a differential of a rectangle. So the centroid of the shape is going to be whatever I measure it right there, because this distance is the x, and the x is a line, let's say. My x is going to be measured from here to here. However, now I have to measure y. And that y has to be measured to the centroid also of that shape. But now this is a line. So the centroid of that shape is going to be at the center of that line. And the distance y that I'm measuring is this distance from here to here. That will be the distance y that I have to measure. Always to the centroid. Remember? Now I have this. Like that. And my distance y has to be measured from here to here. That's what I'm looking for, that distance. It's not just divided by 2, because it's not divided by 2. If I take this distance, which I call, in the first one, I call it h. This is h, right? We call this h. So if we divide h by 2, that's not correct, because h divided by 2 is just giving me either this or that. That's h divided by 2. Then the correct distance will be this one, which we call this, in this problem, we call it y2. Y2? Yeah, we call it y2. Y2. Let me put it here. Yeah, this distance here, that distance, which is whatever you have here, y, it's gonna be the value for y plus h divided by 2. So that distance, which is called y wiggly, or they call it like y wiggly or y, I don't know, tilde or y something, it will be the value for y, which is 1 over 100 x squared, plus half of that h distance that is over there. That h we calculated before as somewhere over the rainbow. Here, that was h, x minus 1 divided by 100 x squared, because it was this minus this. So that would be 1 over 100 x squared. Remember, this comes from that distance. And then the h divided by 2 is x minus 1 over 100 x squared divided by 2. And this will correspond to that little part. So we can do like that, and that will be our y, the y that we are measuring. Or another way of doing that y, and then you can solve for this, right? When you solve for this, what you're having is basically 1 divided by 100 x squared plus x divided by 2. And this is also divided by 2 here, so 200. Or I can say this plus this divided by 2. When you solve it, I mean, you can get this expression. the other way you can do that, or you can interpret that distance also if you use the vertical strip. This is the vertical strip. Now I'm going to focus on the top part of the vertical strip, which is that one. And this is y equal x as per your equation here. So that will be y equal x minus this distance. Remember, we're looking for this distance y. That distance y. So that y tilde will be the total, which is in this particular case will be x minus this. But this is the same as saying h divided by 2. Like that. And then you're going to get the same thing, because this is going to be x divided by 2 plus 1 divided by 100 x squared. So whatever you use, either this or that, is the same. And now you can use the same thing that we did before. Now your limits are going to change, obviously, because now your limits are going in the x direction, in this direction. So if you want to keep going using the same approach that we use here, which sometimes is easier, in this case, I don't see any benefit of doing this. I just want to show you that you can do it. It's y times dA. Now this y wiggly times dA divided by the integral of dA. Now this y wiggly is this value, or this value is the same, exactly the same. So x squared divided by 100 plus x divided by 2. That's the value for that, multiplied by the differential of area. And the differential of area is that big thing over there, this one. What's the differential of area that we got before? I don't remember. Here, this is the differential of area. X minus 1 divided by 100 x squared. And all of these, integral of that, dx, integral of dA. Now, of course, in this case, this is way longer if you do it like that. But this is just answering the question to somebody. Can I use the same differential of area? Yes, you can. In this case, it's counterproductive. It's going to take you more time to do it. So try always, if it's a complicated shape or area, I don't know, weigh the benefits. I find this little straightforward compared with this. That's super straightforward to me, instead of having to use the same differential of area for both. Now, there are problems, by me saying that, there are problems that you cannot use the same approach. And one of them is in your homework, but I explain how to. Yes, it's kind of the midpoint between the two lines. One of the problems, I put it in the homework, and it's kind of in your hands-on homework also. One of the problems is this. Whenever you have to do something like that. For example, find the area and the centroid, or moment of inertia, why not? But find the centroid of this. So if you have to find the centroid of that, remember the equation of centroid is very easy, x dA divided by the area, and y bar is equal to y dA divided by area. And by area, I mean the integral of dA. Now you have to do that. If you follow the procedure, let's say that I have to find y bar. Okay, find y bar first. How do we find y bar? I have to measure a distance y. A distance y, measure from here. And then I have to find a differential of area. Okay, perpendicular to that, the differential of area. Differential of area. And then you have that equation. Give me an equation that reflects that curve really quick. Give me an equation. Five, four, three, two, one. Any equation. Any equation that is correct. Y squared is not correct. Y squared plus 2 could be correct. Okay, let's say that this is y squared plus 2. That equation over there. Y equal x squared plus 2. No, y squared plus 2. Okay, x squared plus Let's say that you have that equation over there, y equal x squared plus 2. So then this distance is y. You have it from there perfectly, and no problem whatsoever. Now what happened? My differential of area, it will be that distance, x squared plus 2 times dx, and that's it. And when I solve this, I can solve it really easy. Now what happened if I want to do this one? And that's the problem. And that's when you have to use the other approach. So if you have that and you try to follow the same procedure, and you have to, you can say, okay, no problem. I'm gonna measure the distance x. Okay, and I'm gonna measure my distance x. I measure y from here. Look at that. I'm measuring x. This is x. This is the approach for this one, not for this one. I was going all the way around. So I did this, right? X dy. Now I'm gonna do this one, and I'm gonna measure the distance y. I'm gonna measure the distance y, and this has to be my dA, perpendicular to that. But if you realize that dA here or here is not the same, because it changes now. It's affected by that curve. Now in this part is this, and in this part is that. The only way that you can do that is if you combine two shapes and say, oh, this is a rectangle and this is a parabola or something like that. But it's going to be a pain. So for this particular case, you could use the same differential of area that you used before and say, oh, but look at that. If I use this differential of area like that, I know the differential of area is y times dx originally. But the distance that I'm measuring, before it was going to that point, now it has to go to the centroid over there. And that's what they call the wiggly or the tilde or whatever they are called, that y bar over there. Now, when you put that in there, remember you have to calculate this. Now, what is this? This is why somebody was saying half of the distance, half of y. But it's not always half of y. I like more the comment that somebody did. Let me see who did the comment over there. Let me give credit to whoever did the credit. Colin, he says, so you just take the midpoint. Yeah, basically you are taking the midpoint of the differential of area. What happened in this case is this is y equals 0, and this is y equal x squared plus 2. So the midpoint is going to be right there because this is 0. But if you have two shapes, you should take the midpoint of those two shapes over there. So these are, in this case, you have to really use this approach in order to solve the problem. And when you do that, then you have to say that y bar is going to be the integral of y divided by 2. But y is that? So it's going to be x squared plus 2 divided by 2. That is this times dA. And dA, you use the same dA that you used before, x squared plus 2 dx. And then you put the limits in the x direction, x1 and x2, which in this case will be 0, and whatever the other limit here is. Now somebody was asking me, is there any way that we can use the second approach to the moment of inertia? Yes, you can use this approach for moment of inertia, of course. Now, if you have the same situation and you want to calculate the moment of inertia, for example, I sub x is the integral of y squared dA. And I started the same way. You measure x or you measure y, and you put your dA perpendicular to x or y, and then from there you start working. But in this case, same thing is going to happen. So if I measure y, imagine that I'm measuring y, and my dA cannot be like that. So in this case, I have to integrate this thing here. So what is the common procedure when you're doing with a moment of inertia is saying, oh, if I want to calculate I sub x, I can say that I sub x is the integral or the derivative of I sub x. There are 4 people waiting. Admit them. There you go. Now the people in YouTube are gonna go crazy, but I say, how can I get access to these explanations? Well, then you go to the paid part of the YouTube channel, which it doesn't exist, by the way. You have to enroll in my class. You have I sub x is the integral of the derivative of I sub 0x. And if you remember, I sub x is equal to I sub 0 plus a times d squared. In this case, y squared, like that. That's what is happening. So if I'm taking the derivative of that, basically I'm saying, oh, I have a derivative of this. What is this value? If you look at this is the x. And what is this value? This value is the value of the function. Y equals the function. So this is going to be y equal, in this case that you gave me, x squared plus 2. That will be the value for y in this problem. Now, if you want to put 2 and 2 together, then we have to do that. What is the area of this? The area of this. So let's talk about this. Dix is going to be equal to what? It's going to be I sub 0x, which is bh cubed divided by 12. Remember, for a rectangle, bh, I sub x is bh cubed divided by 12. That will be the value for the rectangle. So if I say that, I sub 0x here, I should say it here also. So this is going to be dx times the function to the third divided by 12. Integral of that. Plus area. What is the area? Well, in this case, it will be the differential of area times the distance in y squared. Differential of area. What is the differential of this area? Is dx times that. So it's going to be x squared plus 2 times dx plus the distance squared. That distance is going to be the distance from the axis to the centroid. That distance over there. And that distance is the same thing as they call y wiggly, which in this case is y divided by 2. And y, if y is x squared plus 2, that was the value for y. So then I'm going to have times x squared plus 2 divided by 2 squared. And then I solve that. Of course, between x1 and x2. Now, try solving that. But there's another thing, and I don't have time to tell you every single trick. But I'm gonna show you something regarding this type of situation that hopefully is gonna improve the timing for these type of problems, especially with moment of inertia. Now, when I went through the lectures for moment of inertia, and if you go to the back of your book for moment of inertia, back of any book actually, but if you look at the moment of inertia, you have this equation, 112 bh cubed, 1 over 12 bh cubed. However, if you look at my lectures, online lectures, we found that the moment of inertia, we did 2 things. I did the moment of inertia with respect to the centroid of this, y0, x0. And I say the moment of inertia with respect to the centroid is bh cubed divided by 12. But then I say, what if I want to transfer that moment of inertia to 2 axes? And that's why it's called parallel axis theorem. So we are trying to transfer the moment of inertia here. Okay, what is this distance? This distance here is, if this is h and this is b, this distance is h divided by 2. And then we say, okay, the moment of inertia in x is the integral of y squared dA. But what is y? Y is the distance between that I'm measuring now if my axis is here. And what is this? This is my dA. I'm repeating this from the lecture that I had. This is y, this is dy. So basically what you're doing is the integral of y squared times dA, but that dA is b times dy, b times dy, and from 0 to h. And then when we calculated that, we got that by cubed divided by 3, or bh cubed divided by 3. Oh, look at that. This is the part that I was looking for. This one refers to the centroid. This one refers to an arbitrary axis that passes through the base of that differential of area. So if I have these type of situations in moment of inertia, I'm going to use a new page. I'm sorry for the trees. But if you have that situation in moment of inertia, I'm going to go to the same function. And you have to find this moment of inertia, and you want to use that differential. We said before that moment of inertia is going to be the integral of dix, and I still agree with that. But instead of me using this complicated, I don't know, where's the other page? Yeah, here. No. I don't know, somewhere. Instead of me doing this complicated thing to do, because this was referred to the centroid and then I was pushing it back to the axis, what if I use here the one that I just derived? This one with respect to the axis. So I can derive this one, and I can say that this is x and this is y. So my dix with respect to the x-axis, dix with respect to this axis, not with respect to the centroid, with respect to the axis, is going to be equal to this dx times y to the third divided by 3. See the difference here? Here, I did it with respect to the centroid and add the AD squared. Here, I have an equation that allows me to do it only with respect to the base. When I do that, I can do the integration of this instead of doing that formula. Integration of y to the third divided by 3 dx, and y is that value that you put over there from x1 to x2. Now compare this integral with that integral, or those integrals. And if you do it, you should get the same result. So I encourage you to do this and to do that and see what is happening there. Any questions? No? A new message. What is a new message? How do we define? It's a rectangle. How do you define base and height? It's a rectangle. Shouldn't that red y be x? Yes, I said that before. You're talking about this one, right? This one here. Yeah, that's x. I corrected it. What else? I don't know. That's it. So when is your homework due? Your hands-on homework due? Okay, only one person is sufficient. Yeah, I got it, tomorrow. Okay. Will you be really mad at me if I make it due on Saturday night? No? You don't want me to do it? No? Okay, then don't do it. Oh, you want me to do it? Okay. Then I will do that. Let me stop this recording if it was recording. Hopefully it was recording.